Hi everyone. In the last presentation, we have discussed about the character array and character pointers. In today's session, we will again explain in detail about the character array and character pointers. Let us have the discussion regarding the character pointers and character arrays. See, you take a character array. For example, I'm writing character C1 of 10 is equals to we are writing like this. Good. This is a character array, and we know it is stored like this. First character is G O O D. So remaining locations are filled with null characters, and each character is enclosed in single quotes. Already we discussed, and every character is having its own address. Generally, the addresses are specified in hexadecimal, but I'm writing in decimal for our convenience. Assume that the address is 100. It is 101, 102, 103, and this is 104. Here the array name is C1. Array name C1 is nothing but the base address 100. C1 itself 100. Please remember. See, to differentiate this character array and character pointer, if I write hash define, for example, pi 3.14, then the meaning of this is wherever I write pi, its meaning is pi is not a variable. It is constant whose value is 3.14. Similarly, wherever or whenever we use the character array name C1, it's like this pi. C1 is, we can call it as constant, character constant pointer, character constant pointer. Character pointer is different, character constant pointer is different. Or simply we say it is a constant pointer, but whereas character pointer is an ordinary pointer. So I will give the difference exactly. Okay, now wherever we write C1, it represents the value 100 that we call it as the base address, or already I said starting address, right? Now I'm taking a character pointer, character star of PTR is equals to, I'm writing like this. This is another string literal. This is also a string literal, and this is also a string literal. If you write good in C of 10, where the good is stored in C1, C1 is the variable where it is going to store. This entire memory is occupied in the stack, or we call it as random access memory. Please remember the variables and the values are generally stored in the stack, right? So the values or the variables which are stored in the stack can be modified. But when you consider the second one, star ptr equals to bad, the string literal bad, where it is going to store. See, character star ptr equals to bad in the sense ptr is the variable, right? PTR is the variable. Assume that the address it is going to contain is 102. 102 is the address of some storage where the word bad is stored, right? Assume that the address of first character is 102 and this is 103, 104, 105. Whenever we say character star PTR equals to bad, the meaning is that bad is stored at somewhere. We don't know the exact memory location. Bad is stored at somewhere, but whose base address is stored in the PTR, the base address is 102, and the variable PTR is stored in the stack. Like C1 array is stored in the stack, and good is also stored in the stack. Good is stored in the stack. Why? Because here we are specifying that good is stored in the character array C1, which is stored on the stack. But here In the character pointer, we know that the pointer variable PTR stored in the stack or random access memory, which stores the base address or which consists of the link to the storage where the bad is going to store, but the exact memory where it is available, where the bad is going to store, is not known. So this we call it as read-only memory. That is the main difference between character array and character pointer. So we can easily modify the values of the character array, but we can't modify the values of the character pointer. Why? Because we don't know exact location. At the same time, the string literal which is pointed by the character pointer are stored in the read-only memory, which cannot be modified. This is very, very important, right? Now, for example, here we are saying character star ptr equals to bad. Okay, now here I'm writing the statement ptr is equals to, I'm writing C1. Can I say like this? ptr1 equals to C1. What is C1? Character array name. What is ptr? Character pointer here. Can you assign this? Is it valid? Yes, it is valid. The meaning here is the variable ptr1 consisting C1. C1 is nothing but how much? 100. That means it is pointing to good. So whenever you print ptr1 here, it is going to print good. So before assigning ptr equals to C1, when you print ptr, what it is going to print? Bad. If you print C1 here, what it is going to print? Good. Now, another important thing is, can you say, instead of saying ptr equals to C1, can you say C1 equals to ptr? Can you assign like this? So this is wrong. I think by writing these two statements, you can understand the difference between the character pointer and the character array. See, ptr equals to C1 we can say, but C1 equals to ptr we can't say like this. Why? Why? Because I will give one example. Can you say 100 equals to, for example, the variable ptr? Can you say 100 equals to ptr? This is not valid. Similarly, C1 equals to ptr is also not valid. Why? Because C1 here it is constant. C1 itself 100. We cannot assign constant value to a variable. Sorry, we cannot assign a variable to the constant. This is not valid. It is illegal. This is not valid. But what we can say? We can say ptr equals to 100. That means we can say ptr equals to C1. What I want to mention here is C1 itself represents the constant base address. It's not a variable which stores address. Itself a constant. Whereas ptr is the variable which consists of the address of a string literal. That's the main difference. Now, after completing this, next I'm moving to another important thing is, if I say C1 of 0, the first character, what is the first character of C1 of 0? So C1 of 0 here it is, this is C1 of 0 and this is C1 of 1 and so on. Now, when we say C1 of 0 equals to, for example, you can take any character, for example, you can take any character, you say B. When C1 equals to 0, C1 of 0 equals to B, then automatically what happened? This G will be changed to B, right? This is valid. Now, another important thing is, can you increment C1 plus plus like this? No, this is not valid, wrong. Why it is wrong? Why? Because C1 is 100. How can we say 100 plus plus? This is not valid. Okay. Now, just now I said PTR equals to bad, okay, character pointer, right? Now, can you say PTR of 0? Can you say PTR of 0 equals to some C? No, it's not valid. You cannot access the first element like P of 0. Okay, you can print it. Now, for example, can you say PTR plus plus here? This is called pointer arithmetic. PTR plus plus, can you say? Just now I said it is bad. The last character is null character. Okay. Assume that this is 102, 103, 104, 105. I said PTR is the variable which consists of the address 102, which is pointing to this memory This memory is read-only memory. We don't know exact memory location. It is not stored in the stack. Now, PTR is a pointer which consists of address 1 or 2, which is a base address. That means which character B. Now, if you say PTR plus plus, then automatically the meaning is PTR is incremented by 1. When we say PTR plus plus, the PTR is going to move, sorry, to the next location. Next location means it is pointing the base address 103. Here it is going to say 103. Now, when you print here PTR, then what it is going to print? It is going to print AD. This we can do. Now, can you say PTR equals to, can you assign a new string like this by? Yes. So, in this case, what happened? By is stored in a different memory location like ROM. Previously, PTR is pointed to bad, which is stored somewhere in the ROM. Now, when we say PTR equals to by, we are not modifying here. We are storing another string literal by in another memory location, read-only memory location, B, Y, E, and last character is and this is pointed by some another variable PTR. Previously, PTR consists of 1 or 2. Now it is going to store another address. This is possible, right? Can you say here C1 equals to a new string? For example, hello? No, it's not possible. So character pointers can be incremented, but the character array cannot be incremented, right? This is very, very important. So with this, we have clearly explained the main difference between the character array and character pointer. Another important thing, yesterday we discussed that if you want to read a sentence or a string of multiple words by using scanf, we can use the format specifier like this, but here you have to mention percentage and last you have to mention s. Instead of using this, you can also use getS. This is the clear picture about the character array and character pointer. Now, another important thing I want to discuss here is why we are not using for loop while reading the string. Why? Because a string is the name of the person, the length of the name is not fixed. We don't know how many characters the string is going to contain or the name is going to contain. The end of the string is only known by pressing the enter key. Whenever you press enter key at the keyboard, then it indicates the string has ended. After pressing the enter key, then the null character is inserted. So for that purpose, we are using percentage %s. We are not using any for loop. This is about the discussion. Now, we use another important function in the string. We can use, we are going to use putchar. Not only putchar, we can use putch. Okay, these are the character functions. And we have used getS, right? Gets or puts. These are related to strings and these are related to characters. Not only this, we can use getChar, right? Getch, getche. We will discuss these in detail when we discuss about the input-output functions. So we have formatted input-output functions and unformatted input-output functions. So we will discuss all these at the time of discussing input-output functions. But here, I want to discuss an important function that is putchar. So if you want to know the syntax of the putchar, the syntax of the putchar is given as integer putchar, and it is going to take integer character. See, the very, very important thing is the character type variables can also be denoted as integers. Why? Because the character constants are going to take the ASCII values, which are again integers. So please remember. So if you take character ch and if you say ch equals to a, instead of using this, you can directly take the data type integer ch and we can say ch equals to a. Both are valid. Why? Because the characters are internally represented by using their ASCII values. Now, what is the meaning of this putchar? Putchar is going to take a character and it is going to display on the screen, or we can say console. After printing this character, the character is returned. that is int. So what it is going to return? It is going to return the ASCII value of the given character. So that's why the return type of character is int. Now we will see how the strings will be implemented using Visual Studio Code. Let us go to Visual Studio Code. Now we will see how to implement the strings using Visual Studio Code. Go to Visual Studio Code and go to the new file and you write strings.c. I'm writing strings.c. Okay, now how we are going to implement the strings. So here I'm writing just a program to implement strings, right? See, first I'm writing hash include stdio.h. Okay, now integer main, and after this, see here we have to declare the character array first. Character, I'm writing s, or you can take any string name, character s, and the maximum size, assume that I'm taking 10, right? Character. See, after saying character s of 10, you can't say s of 10 is equals to, for example, hello. We will check whether we are going to get any error or not. It is not valid, right? And for example, assume that I'm saying printf. How to print a string? %s, double quotes close, comma. Here ampersand is not required. Already we discussed. Just you give the name s. Okay. Now last statement we write return 0. See whether any error is there. Compile it. See, it is giving error. See here. We got an error. First it has given error. I think you have identified the error. And it is not going to print anything. Hello is not displayed. We got an error. Okay. Here we got error. You see here we are showing this. So we can't say like this. So the declaration and the definition should be done only in a single statement. Already we discussed that. So before semicolon, what you say? You say hello. Hello, right? Control S. This is valid. Now run it. It is going to print the string hello. You see here we got hello. Okay. Now I'm using another notation character pointer, character star ptr pointer equals to world. You can use anything. Okay. Here character pointer ptr equals to world. Now here I'm saying printf. Same notation I'm using %s. Here I'm writing ptr. So the difference between s and ptr, s seems to be a variable, but it is not a variable, it is itself constant. But ptr is the variable which stores the address. But s itself address, that is the difference. Now save it and you execute this. See, we got hello and world, both are printed. Okay, but there is no new line character, so that's why we are printing in the same line. So second ptr prints world. Okay, now if you want to new line, just you write here, it is /n. Here also you write /n for convenient purpose. You say Control S and you run it. Now we have hello world. Now the thing here is I'm going to modify the first string. So how to modify? Just I'm saying that s of 0. First character is already h, but I'm going to change it in a single quote. What I'm going to do is I'm writing like for example m. Okay, now we will check it what we are going to get. See, run it. See, first we are printing mellow and second one is world. This is okay, right? It is modified. And next, what I'm going to do is, I'm trying to say ptr of 0 is equals to, I'm writing a new character h. H means you are expecting that old. Okay, something I'm writing. You can write anything. Okay. Now you press Control S and you check whether there are any errors. It is giving error. It is not printing anything. It is giving error. Okay. It's not printing anything. It is giving some error. Exception has occurred. You see here. Exception has occurred. Segmentation fault. Why? Because we are trying to modify the memory, read-only memory. It's not possible. Why? Because we are using the concept of the character pointer. We are using the character pointer. So this ptr of 0 equals to h is not valid. Why? It is not modified. Okay. Now, can you assign a new string for this? Instead of saying ptr of 0, can you say only ptr equals to, I'm writing like this, hello world. Can you assign a new string? Yes, it is valid. Why? Because we are storing a new string liter hello world, which is stored at somewhere in read-only memory, which is pointed by the ptr, where the ptr is going to store the base address of small h. This is valid. Okay. Now, what about the first world? World is stored at somewhere which has pointed by star ptr or ptr, but it is here, it is updated and it is going to store the base address of another memory location where hello world is going to store. Now you run it. You see here mellow and hello world. Here it is printing first mellow and second one new string we have stored hello world. So it is printing hello world, right? Now, can you increment the pointer s, or can you say yes plus plus? Okay, you check it whether there are any errors. Error, right? It's not possible. Okay. Now here what I'm going to do is, it is not possible. But the character pointer can be incremented. Here I'm writing ptr plus plus. ptr plus plus. When we say ptr plus plus, we are talking about the pointer arithmetic, then it is pointing to the base address of the next character. ptr plus plus means, so first it points to h. When we say ptr plus plus means it is moving to the next memory location. Incrementing 1 means it is moving to the next location where it is going to store the base address of e, and we are printing it as a string, so that's why it is going to print LO, ELLO world. We'll check it. You see here mellow, last one is LO world. So this is about the practical clarification regarding the character array and character pointers. Now I'm trying to read these strings from the keyboard. For example, here I'm not deleting this. Okay, you can take any here character pointer. Now you say printf, enter the string, and you write /n, and here you write scanf. See here I'm writing this control X. Here I'm writing control V. Scanf. Here what you do is, you know how to read a string %s, double quotes close, comma. I'm going to read into first two character array s. Next printf. I'm going to say another string, enter another string, /n. Here I'm writing scanf %s, double quotes close, comma, ptr. Okay. Now we are going to print two strings, printf percentage s, yes. Okay. Better to write /n for clarity. Next printf double quotes you write percentage s double quotes close comma you say ptr. Last statement you say return 0. Okay. Now we will execute this. Control S. Now run it. Enter the string. First string it is asking, hello, how are you? I'm giving the string, hello, how are you? Hello, how are you? Enter another string it is saying. See, whenever we say and hello, how are you? It is saying segmentation fault. Why we are getting this segmentation fault? Why we are getting this segmentation fault? Why? Because we have entered hello, how are you into S. But what is the size of S? 10. So that's why it has given the segmentation fault. Please remember this. Okay. Now I'm running. Just you enter maximum 9 characters, including null character. It is going to take 10. For example, I'm writing here. Here I'm writing this. Enter the string how. How are you? How are? Just I'm writing how are. Again, it is saying a segmentation problem. Why it is giving segmentation problem? Exception. We got again exception. Why? Why exception? See here we have written HE. Okay, wait. Control S. I'm writing a string. Okay. Just wait. Control S and you run it. We are saying first string hello. Okay. Now, okay, we are giving first string hello. Enter the second string. And second string we are going to give is world. Any string you can give world. So it is saying the error exception has segmentation fault. What is that exception we got? Where it has the error has occurred. Okay. See here, the problem here is with the character pointer. Enter the another string. Where it is the error? Check it. See here, the problem here is we are trying to read the string into character pointers. Okay, so we can't read the character string into the character pointer from the keyboard. So that's why we are getting the segmentation fault. You see the statement scan of percentage s comma ptr. It is not valid. Why? Because you have to store only the string literal. Directly you can assign here like this. Hello. But we can't read the string from keyboard. We can't use this scanf statement which is associated with the PTR. This is very, very important. So that's why we are getting the error. So if you remove this and if you say PTR equals to some hello and you can now print the printf. I'm removing the, I'm keeping scanf in comments. Now you try for this. It is asking enter the string. For example, I am writing good. Good is the first S string stored in S, and second one is enter another string. It is saying just we are printing enter another string, but we are printing S. S is good. PTR is how much? Hello. But scanf is not accepted with the character pointer. So this is about small things to implement the strings. So more details we will see in the next session. With this, I am going to close the session. Thank you for watching.